Well, that took longer than I thought. That's cool. All right, you ready?
We begin.
You guys remember taking the derivatives of arc sine, arc cosine, arctan? And the derivatives were messy. So are the integrals.
Yay.
Yeah. I don't think I give them to you. But there's only 3 of them. You don't have to do the other ones or find that relationship. There's only 3. Okay. So you guys, basically anything that is of this form, you won't be able to use one of the other techniques. So like I almost view integration as start with easy techniques, and as it gets more and more complicated, then you try one of the more complicated techniques. So like I could look at this one and I could say, oh, I could maybe try to do U sub, but it's not going to work. If I did U sub, what do you think we would do? Yeah, like we would try probably 1 plus 9x squared, and then du equals 18x dx. And I can't turn that 12 into an 18x dx. You guys see what I'm saying there? So when the U sub doesn't work, that's when I'm going to shift up a little bit and try one of these. Okay? So obviously I would not expect you to have them memorized yet. But which one does question A look like? Arctan. Is everybody with me? Okay? And so I'm going to kind of do a couple of things here. I'm going to call this 12, 1 over 1 squared plus 3x, the quantity squared dx. Just so you can kind of get the feel for.
Or is it 1 over 12?
No, it's just the 12. 12 is a constant. I just moved it out front.
Okay, yeah.
And as I look at this, I would get A equals 1, U equals 3x. So the 12 out front times 1 plus arctan of 3x plus c. I think we might have a problem with this.
What?
You guys tell me. Du equals 3 dx. It's not. It's times. Sorry. I have a problem with our answer though. Yeah, we got to divide by 3. So before we can do this,
is that arctan?
Think of it as du equals du over 3 is equal to dx. Yeah. So as I go to rewrite this in this form, I would have 12 times the integral of 1 over a squared plus u squared times du over 3. Think of it that way.
Are we not allowed to take the du out? Like the 3?
You will, yeah. So then I might call this 4 times the integral over 1 over a squared plus u squared du.
Oh, wait, so that is u sub though, isn't it?
I'm sorry?
That is u sub though, right?
Yeah. We're using u sub within a more complicated formula.
Okay, I thought you were saying we couldn't use u sub for this at all.
We can't use, we're kind of doing, yeah. So this is saying 4 times 1 arctan 3x over 1. So just 3x plus c. Mm-hmm.
Can the H still be 1?
It is what it is.
Why did we change it to
Because that's right here.
Okay, you guys,
I
what's
know, but
She
like,
just
what's this one look like? Which one? Arcsecant, yeah? Okay. And in this case, A equals 5. U equals
Yeah.
3x. 3x. Du then would equal du over 3 would equal dx. Are you guys comfortable? Can I just say it that way? Dx. Du over 3. Oh, because it's whatever's being squared.
Even though it's technically not on the outside.
It's
yeah, it's just see it as one term. Like if we were to use of that.
it's gonna come back up. We're not. And you guys, that would also mean that x equals u over 3, yeah? Okay, so if I take this and I rewrite all those substitutions, I will have, I'm gonna pull this 2 out front. What should I fill in for x?
U over 3.
9x squared, u squared, minus a squared.
Which is
Is this okay?
Wait, isn't it 2/3?
No.
6.
Like,
Yeah, so we're gonna talk about that over 3 next.
Oh, okay.
You guys, this over 3 is in the bottom. So I'm saying 1 divided by u over 3.
Equals 3 over.
Isn't that the same thing as saying 2 and making that 3 over u times 1 over the square root of u squared minus a squared du? Oh, yeah. Yes. Because the du is over 3. Yeah. Are we feeling okay?
So arcsecant.
Two arcsecant. Wait, that's not right.
1/5. 2 times 1/5.
So 2/5 times arcsecant of
U.
3x over 5. The absolute value of 3x over 5.
So are we going to memorize these rules or are you giving it to us?
Okay, so this will be the third time I'm answering that question. I'm not giving them to you.
Homework packets to Monday.
No, the homework pack will be due Tuesday.
Wait,
Plus C, right?
Plus C.
if you multiply 2 to the 2/5, would you have to multiply 2 to all of them? Or,
Say that again?
because you said 2/5, and I'm assuming that's just from the.
That's the 1 over a.
Yeah.
But this is, no, because the 2 is just being, you should think of it as this.
Okay, yeah. okay,
Right?
so I remember
But so like when you think about it, the 2 times the c doesn't matter.
Right,
So then it's 2 times that entire piece,
right.
which is just 2/5. And just put the 2/5 in front.
Oh, okay, I got you. Is it okay if we write it how, like, we leave the 2 and then parentheses the whole thing?
Yeah, I don't care about that. I I don't know any techniques I can use. So what we need to do is rewrite this so that it is in the proper form. Everybody with me? All right. Now to do this, we're going to use a process that, you did learn at some point, but you may or may not remember it. The name of this process is called completing the square.
I know the name.
I've heard that name.
Okay, so let's do a real quick sidebar on completing the square. Cool? All right. You guys, what is x plus 3, the quantity squared? X squared plus 6x plus 9. Are you with me? And in order for that to happen, in order for it to be a perfect square, this is 2 times 3, and this one is 3 squared. Yeah? So if I gave you x squared minus 10x plus c, and I said, what value of c would make this a perfect square? It would be 25. And how are you getting that 25? You're doing the negative 10 divided by 2 is 5, negative 5. And then when you square that negative 5, you get positive 25. And then the result of that is x minus 5, the quantity squared. Everybody good? So for right now, let's ignore the 7. And say I have x squared minus 4x plus something. What do I need that something to be so that I end up with a perfect square? 4. So if I want to make sure I stay equivalent, what value do I need to place here so that the bottom continues to have the same value? 3. Everybody good? So I could rewrite this as the integral of dx over x minus 2, the quantity squared, plus the square root of 3 squared.
Could you also just have separated the intervals so that'd be like 1 over x minus 2? Or no, I guess the whole denominator.
You're still going to run into that chain rule issue one way or the other. Okay. Everybody good? We feeling it? Because all of our patterns are a squared, just to help see why a is the square root of 3 instead of 3. All right. So which one does this one follow, y'all? Arctan. All right. And we have, let's see, a equals square root of 3. U equals x minus 2. Du equals dx. And let's see, I'm pretty sure that works out to be 1 over square root 3 arctan of x minus 2 over the square root of 3 plus c. We feeling okay? Yeah.
Actually, quick question.
Yeah.
Since they're in the arctan one, since like A and U are like I just added together, how did you differentiate between which one's A and which one's U?
A is a constant. U is a function.
Okay.
That's a great question, Ben. Yeah.
Well, we have to use like the completing the square and like the division thing with the box on the test.
I think that it's reasonable to assume that I taught them to you because I intend to test you on them. I think that's reasonable to assume. Yeah. All right. What are you guys thinking for this next one?
You could take out a square root of that line, but that doesn't make sense.
I agree.
And we're just taking out y. Make it like 4 over y. That's the other.
Does that look like it's going to start matching our forms?
Yeah, sorry,
So you want to do the integral of, so you want to do this.
But then you have to
Is that, because that's what we would end up with if we pulled out, you with me?
Yeah.
no, conjugate verbs come out, but no,
Any other thoughts?
How do you separate the square root?
Not with a plus sign, you can't.
do you complete the square?
You can, yeah. To complete the square, so the first thing I'm going to do, just to make the completing the square part feel a little bit better, okay,
I see.
is for right now, I'm going to pull a -1 and make this y squared minus 4y. Something about this isn't feeling great.
So there would be +4 and then -4.
Sort of. It would be +4 and +4 because of the negative, yeah. So now we have the integral of 2 over the square root of 4 minus y minus 2, the quantity squared, dy. How are we feeling? Does this feel pretty decent? All right, so now what are we looking at?
A is 2.
A equals 2.
B is y minus 2. But you have to take the 1/2 out as well.
Say that again.
Like, because the d, there's a 2 on the top.
Yeah, so for kicks, let's just do this. Pull that 2 out front so it doesn't get confused with our integral. Are we good? All right, and which form is this one? Arc sine, right? And it's arc sine of u over a, so that'd be y minus 2 over 2 plus c. How are we feeling on this? With the formulas, I don't think these are that bad.
Wait, where did you get the +4 on the very first one?
Because, like, so first of all, this isn't a +4. This is a -4 because of this minus sign. And I have to,
Yeah.
but I have to counterbalance whatever so that overall it still has the same value.
Okay.
You, challenging than this problem. I think that's the hardest one on the page by far. Do you guys want to do some more practice with these?
What do you mean by this one? How many sides of die that James will likely have?
Like, there's all sorts of dice, right? Like, they're not just six-sided dice.
So many over one?
So if this is the percentage.
Oh.
Okay. We ready? What are you guys thinking about this one? I got a lot of different ways I might think through this one.
Is it U or K times? U. Could you, can you make it x plus 2 to the negative first? Like the whole thing? And then put it in the bottom?
Okay.
Separate. So there's like an extra one and then 2 of the other.
So you want to do x. Does that help us?
You could solve one of them. The other one, I don't know.
Which one can we solve right now? This one? Guess what? You can solve this one too.
Put X on the bottom.
Well, U substitution?
This one, the left-hand one, you can solve using U sub. The right-hand one, you can solve using our sign.
We were quizzing at lunch today, I guess.
Mm-hmm. How we feeling?
Can you go over one more time, like, how you, like, find A and how you find U when you're doing?
A is the constant that's being squared.
Right, and then U is just,
The function that's being squared.
okay, so since it's x squared, U is just x.
Negative. I think. Oh, wait.
No, because the minus is part of the arc sign.
Right. Grab this
Do you
one.
not need a plus C for the first one as well?
Well,
No, that's.
it's all one giant answer. So the plus.
Put it twice though, would that be too much?
No. I mean, ideally, I would not have a problem with you putting it twice, but then I would probably like. I think it would have to be like a plus C1 plus C2 because they're not necessarily the same constant. And then call that but like you could also get into the habit of adding the plus C when you're done. Like it's fine.
So it's this, right? This is a U.
Are we feeling okay about these? Again, if I give you these patterns, the worst case scenario is I think, in my opinion, the worst case scenario is the completing the square. It's not going to get more. All right, before we get too much further, I want to kind of talk to you guys about what this looks like. I kind of have two options for us in terms of what comes next.